Okay, so for this part, we have two small parts for the afternoon session. So the first part, we'll try to do a small demonstration of NDN-LITE, and G have kind of introduced you the structure of the package, and for the VM that I put, I give everybody it's already downloaded version of a POSIX set of elements for NDN-LITE. And the objective is here is to demonstrate one of the scenarios that you may be able to use the NDN-LITE or deploy it in some small IoT scenario. Again, for those who are going to be following it, pay attention to the information on the slide. So you will need to connect to this magical, not magical, just simple ESR that demo1 network. The password is very simple, from 1 to 0 on your keyboard. You need to kind of import that VM that I gave you and change the network settings from the NAT, from NAT to bridge network. You don't really need to know the usernames, but if you really want to modify that VM later, the password is simply root. Another one that I will need from you to remember is a little bit of a black magic. Okay, if you're doing this, you can try to do it like right away. The whole scenario that we're trying to do is an IoT scenario. We're going to have one controller, and my computer will effectively act as the controller for the home environment. And then each of your VM that you're playing with will act as an IoT device, potentially some kind of a small sensor you're going to be installing. And in this environment, in the settings that we're playing with, we assume those devices can be pre-configured using QR code. And the effective in the scenario, in the real scenario, this QR code will be printed out on the device, or some printed out and somebody will be stapling it. And as a controller will be mobile phone, and this mobile phone will be just either walking near the sensor or bringing the sensor and scanning the QR code, and effectively first step for the bootstrapping process. And by these magical instructions, I'm just asking you to do this generation of the QR code and giving me the QR code so I can add it as a controller, instead of me walking with a non-existent phone and scanning of non-existent devices. I'll just try to follow the same instructions that I was giving to you in my VM. Okay, at least myself succeeded. Anybody succeeded? Oh, a lot of people succeeded. Okay. Okay, given the number of people succeeded, I'll try to continue. If you still have a problem, screen. So I'm stopping and coming to you. So for another part, so I kind of collected the preliminary stuff, but let me get back to the actual presentation or initiation of the tutorial that I was planning to show you. So for the tutorial app, I already said kind of the scenario that we're looking at is some kind of very small home environment where we have a controller, ideally represented either some phone or some device that's in a system connected to the phone, so you can do various kind of scanning. And your computer's VMs are representing some form of IoT devices, sensors, actuators, and so forth. For the communication, G already mentioned kind of NDN-LITE provides several high-level protocols, and the objective of this demo is just to show how easy or how simple you can bootstrap device if you're using these high-level protocols, and from the perspective of the device, like how many code lines you actually have to write in order to succeed. For the controller, there is actually a project for the controller, and for now we're just using a simple Python-based web server application, which serves you some information, doing some processing. And there's also the NDN-JS-based part that's doing local communication with the NFD and various configurations. I'm not going to be talking too much about the controller itself. I just highlight some of the features in this controller that's so far implemented. So the first step when you effectively setting up the environment at home is to have this controller initialized. And from the perspective of NDN, this initialization means generating the private public key pair and effectively creating your own trust anchor certificate. And this is done automatically as part of this package that I'm showing you, and it just highlights the pre-configured. For now, it's just literally hard-coded the NDN IoT as a name for your home, and some kind of a key that was generated. The other part that's available in this environment is to bootstrapping. So this is the place where logically you go with your phone and scanning QR codes of the devices that you brought into the system. I will try to do the scanning by a little bit cheating. I just running this another controller in different VM, and I said that normally it would run on something different than a VM, maybe a phone, maybe something else. So I started this one as overview. It shows up some information, not necessarily in ideal world. And for the device bootstrapping, you saw something as part of this one. I just show again how can I upload some of the information. In this case, it's just duplicated, so it's nothing really useful in there. So what the kind of effectively pre-bootstrapping process of what just happened is I got some secrets in quotes information from the devices. So now my controller knows the device. Device does. I mean, you as a device, you don't know anything about the environment itself, and kind of your device needs to be properly configured in order to work in this environment. So the assumption is slightly special. Is we're assuming there is only one controller in this environment, and that controller is the correct one. If it's not true, if there are multiple, there's a best controller inside the environment, then that controller needs to be effectively reconfigured at some point at later time.
Alex? Yeah. So that assumption really takes the form of there's one controller, and this is the name that you refer to it by. Does the device need to know the name of the controller?
As of right now, no. So what we didn't show was the bootstrapping protocols. There is a slide deck. There is additional presentations that we recorded to kind of try to avoid spending time on that part.
But that's, I mean, when you say you're going to automate security, that's the part that I always get nervous about, right? Because there's no, I mean, you're doing a one-size-fits-all policy, right? Which is hidden in your magic here.
Okay.
So, I'm not asking you.
I'm
just saying.
Okay, let me a little bit rephrase what G said before. So this is one of the bootstrapping protocols that have some applicability in a small home IoT environment, where you can afford the kind of reasonably tight control over the network, so you're not going to have rogue IoT controllers popping up in the system trying to trick you, or you have ability to reconfigure the device or reboot the device so that you have a hammer and smash it if it's incorrectly configured, then you can just get another one. But I completely agree. For the bootstrapping, especially for the security bootstrapping, it's a very complicated topic, and the protocol that was designed is just one approximation. And the reason I don't want to even talk about this because there's interesting phrases like a private public key or like secret public key in this picture. So that's beyond the point of this tutorial. This is just to highlight some APIs that should be as part of the NDN-LITE. There's one API that is already implemented, kind of this simple SSP protocol, but definitely within this environment we need either the bootstrapping protocols or kind of have ability to do something more secure. I mean, the word more secure is weird because you have to define what is secure in this context is. Do you have more comments?
No, I just want to do a clarification. When I say automating security, I really meant after the sign-on. The sign-on required the shared secret. That cannot be automated to authenticate who is who. Sorry for that confusion.
But it's a very good comment, very good question, because there's a lot of work. I mean, there's one is the security bootstrap itself. Then there's the questions about maintenance, about the ownership, updates. There's tons of different questions. And for the security, so there's another piece of work that I've been trying to start with like some undergrad students is about the secret itself. So like the assumption in this protocol is a QR code, and the QR code needs to be generated. There has to be a private key created in some way. Then the scanning ability and so forth. So I was trying to do something else with the IoT environment, IoT devices under assumption of proximity.
But you're using name-based access control or something.
That's the next step. That's still all of the elements of trust schema, access control. They come in after the device is on. And like, first thing is it needs to have a connectivity. That's the basic thing that is a little bit complicated in some cases. And the second one is have credentials to trust the network and be trusted inside the network. And then after that we can technically build the other things. Okay, so I have run this one. I hope to run this you already compiled this stuff. And so one exercise that I would like you to eventually run is not this one, but if you go to your controller, go back to the build folder and run examples and tutorial app. So this one. So for now we just again a little bit more of black magic. If we succeed, I should see something interesting. No, at least I failed for this part. Okay. If we succeed, I should have like already signed on my device, and I see that somebody else also signed up service.
I received the service discovery packet.
Okay, so then you succeeded with this. I saw that there at least one device succeeded in a bootstrapping. Okay, so somehow you got lucky, and I have a suspicion that there's something wrong with DHCP server, and somebody is using the same IP address as myself, but it's outside of my control. So in any case, I just so we tried to do compile, we shared the QR codes, and now I just want to go over this tutorial applications just to show a few things that this application is doing and approximately how it's doing, so you can try to maybe play later with your application. Just a small comment. So NDN-LITE is the basic part, so that's kind of the common part among all the packages. But then there's a few different things that are associated with a specific platform. So for like he showed that for the Nordic, there's like one repository and like connecting to several sub-modules, effectively introducing like face adaptation, time adaptation, and a few different things. Besides the kind of the difference in different way the kind of modules are connected, there's also, at least as of right now, difference how things are built. Like the different build systems. So for the POSIX that you're trying, like that I shared with everybody, it's built based on the CMake, so everybody's familiar. For the Nordic platform and for other platforms, it's not yet fully integrated with the CMake, but hopefully we'll figure out the way eventually how to integrate. For now, you have to like import the project to the wherever the Nordic Studio. I think in the README file, it's more specific how exactly it's done. What I want to highlight as part of this simple app, so G mentioned that in order to start communicating, like in order to, the first part of the client or producer application, you need to I mean, there's a part of the initialization where you need to initialize some of the elements of the NDN-LITE itself, security subnetwork, security elements, as well as the either generate the keys or have them loaded from the file that was already pre-generated. And if I open the source code, I open it in a reasonable way. I hope it's visible enough. So the whole tutorial of this application is, it's not too small file, like if you see it's like 281 lines, but it's not too big. Like it's a C file, therefore it's a little bit verbose in some of the components, and there's some argument parsing and so forth. But effectively, what's the first thing that is happening as part of this application will initialize the NDN-LITE components. So this tutorial app is specifically for the POSIX platform. I was trying to highlight to G that so this is not the primary target for the NDN-LITE. It's just for kind of debugging for the illustration purposes, maybe to run in a Raspberry Pi if you really want to just run this very light implementation of NDN. But the primary target is still very constrained devices where you don't have memory, you don't have processing power, and so forth, and very limited connectivity. So some of the parts not going to even exist in the real application, like with all the signal stuff, but some of the elements will exist. So you will still need to load the security credentials. So in this part, it's hidden as part of this parse args. Like if we go back to the definition, let me just. I don't know what I did. So it's simply opening the file and loading this tutorial shared info.txt. And that's the file that was generated automatically, or generated when we run the black magic command that I showed you in one of the slides in the beginning. But again, nothing special, it's just loading some stuff. Ideally, it should be simplified to one command for the loading part, but not there yet. But eventually will be. Okay, get back to the main file. So the next stage is simply creating the phase. So in this scenario, we try to cheat a little bit and create a UDP multicast phase, because that's the thing that is supported on the basic platform. If we're talking about the real IoT device, then it will be creating a phase for whatever network device we're planning this IoT device to work over. So if it's some device for the ZigBee protocol, then it's ZigBee. If we want to run it over Bluetooth, then you effectively will be creating Bluetooth phase and kind of connected internally, so you can start sending interest and receiving data. Then there's a bunch of stuff again for the initialization. What I wanted to highlight is actually these few things. So there's a SD service discovery. So these are two effectively trying to run the service discovery API of NDN-LITE, and there are some of the things that G described in the previous presentation. Here, just I'm trying to show how to use those components. Simply kind of initialize the service discovery, some memory elements that needs to be initialized, and then you can add a new service discovery component. So that's kind of the initialization of the discovery, just saying that we ready to have the discovery, and the whole process, the whole progress in this specific application is done starting from the bootstrap. So kind of the assumption is very trivial. Whenever this application starts, it has it only knows about its own credentials that this QR code credentials that were configured by the system, and it's not part of the system. So whenever you would kind of equivalent of having controller without persistent memory, or not controller, but microcontroller without persistent memory. You put it, it's trying to get bootstrapped on the network, receive credentials from the network, and get trusted anchor from the controller, and then start some publishing information and so forth. If you have a persistent memory, then kind of some of these processes will not be exactly the way we're showing in the tutorial app. But the highlight of this process is we start bootstrapping like with this call and with a bunch of parameters that I'm showing on the slide, and one of those parameters, the most important one, is this after bootstrapping. So effectively, just telling you, we're asking NDN-LITE by one call, please bootstrap, do your magic of bootstrapping. Hopefully, we can define the type of the bootstrapping eventually, like what the kind of process we want to run. And then when you're done, call this after bootstrapping. And if I quickly find this after bootstrapping method, so this one, it's not that great. So as G mentioned, some of the components is not yet as high level. So this one is still setting up kind of name components. We're setting up the name, creating the name, and trying to register prefix to receive interest for that specific name. But at this point, the key part, at this point of after being bootstrapped, we now have credentials to actually verify any commands that anybody will send us. Or if we produce the data that we will produce as a response to those interests can be verified in the network. Versus if you do the same before the bootstrapping, this is not going to happen like effectively. But again, look, you can quickly see it's not as nice as very high-level languages, like when you deal with the memory, when you just deal with the high-level abstractions. But it's not too big deal if you have some snippets of the code already available, so you can write those things. So for the server discovery, the server discovery already works regardless of the bootstrapping. So that's one part that potentially needs to be also addressed in the future. The server discovery is additional protocol that we didn't show in the presentation, but G pointed out to slide decks and actually recorded presentation that describes one version of the server discovery protocol. But effectively, what the server discovery protocol is some form of announcement of what names are available for data retrieval. And as soon as others know what kind of services provided in the network, you can immediately start requesting data. And if I highlight what exactly those things can be as part of the controller, so luckily we got at least one device got bootstrapped. And as soon as the device bootstrapped, the controller also obtained information of some services being published by that device. So it's so the result of so what you're seeing in here is a result of the running service discovery. So, and rerunning, continuously running the service discovery. So right now the controller doesn't process, doesn't understand what this 0B, 0C is, but it is, in one case it represents lightning, the other case represents temperature, but it's kind of application specific, and depending on how application actually interpreted those numbers in the wild. And okay, so the service discovery, it just runs, announces that this service is available, and doesn't do anything. There are no callbacks associated. They just announcing the name. And with the perspective of to actually do some meaningful work, is you have to register prefix if you're expecting to receive interest. And then, as you pointed out before, you need to provide the callback of what should happen when the interest is received. In this case, it's a live service callback. And this one, again, this one is quite simple. I just received that interest, process this interest. Again, not ideally so far, like it's still a little bit verbose, and it should be improved in the future to reduce all this information for the common operations. But effectively, there's a kind of basic checks that kind of name is properly formatted. And an important check somewhere here is signature. As he highlighted, I mean, G only showed, if I remember correctly, this digest verification, but in the system it also supports the ECDSA key verification verification using the CDSA keys against the trust schema, or if you have configured properly the schematized trust, you can just do verification using the schematized trust in addition to just signature verification. And finally, if it's correct, the command will be accepted and things can be proceed to update the lighting. If not, then not. And it also creates a response and putting this response back to the forwarder. So this is just the whole basic example already covered, and it's not as simple maybe like as it's supposed to be. Like some of the elements definitely can be shortened in either some macros or some additional functions, but it's not complicated things as well. Everything is reasonably high level, especially high level for complex protocols like bootstrapping, service discovery. So those things are completely hidden from the application perspective, and kind of the important part, they can be easily changed to something else when the need arrives. Technically, this is all I wanted to show. I have a slide deck I prepared if we didn't go through the source code, but it's effectively highlighting exactly the same components. Just a few small things that maybe I would like to add. Yeah, so all those things are the same as I was showing. One thing is about this magical event loop. If it's a controller, if it's like a real controller, it never stops. So it's always like running, and until you turn off the power. So some of these elements like running through, checking the while loop, the truth will not be there, or like will be completely pointless. But because we run it on the POSIX platform, because we have like Control C ability, we included this component in the system. Yeah, it just like highlighted. We'll post a slide deck later so you can kind of see what exactly the whole tutorial application is. Okay, so we kind of partially succeeded in running. At least people got the VMs connected to us, and I was able to give me the QR codes. Somehow it didn't work fully for the full discovery mode because I was expecting to receive more devices as part of the bootstrap devices, but at least one succeeded, so we have something.